In this video, we are going to start our discussion of section 11.4, the cross product of two vectors. All right, before we do that, we have to do could be a review, could be the first time you've ever seen this. Depends on where you went to high school. Also depends if you took college algebra or not, and where. It is called the determinant. The determinant is something, it's an operation on matrices. Now, a matrix is just an array of numbers. That's all it is. It's a collection of numbers put in nice columns and rows. The determinant, these straight bars, I'm going to define it for you, but that's about as far as we're going to go is define it. We're not going to talk about the properties of the determinant. We're not going to talk about why we're going to use it to find something, but we're not going to get into too much detail. Now, this is something you're going to do when you get to linear algebra, which is usually after DE or with DE. So here we go. The determinant of a 2 by 2 is A1B2 minus A2B1. How I memorize this? It's this diagonal minus that diagonal. That's all it is. Now, unfortunately, that's great for a 2 by 2 matrix. It's fantastic. A1 times B2 minus A2 times B1. Now, a 3 by 3 is not so pretty. This one, I'm going to write it out. You're going to hate it, and then I'll show you how I got about it. So here we go. So let me write out the first component. What we do is we cover up our first column and our first row, and this number right here will be the number that goes out front. The number that goes inside our little 2 by 2 determinant is what's not highlighted. So look here. So we have the inside, we have this, right? That's what we just wrote down, and then that circled number is what goes there. This is something that's not going to make any sense why it's here, and you're just going to have to do your best to not forget it. This minus. This is where I even forget this. Like, as many examples I've done of this, still forget that minus sometimes. So be very careful. All right, how I get the second part of this is I mark out the second column in the first row, and I circle its intersection, and I write down the ones that are not highlighted, B1, B3, C1, C3, and then I put the number that's there, A2. Then we do a plus. It's always a minus, so it's positive minus positive. All right, the third thing I do is I highlight the third column in the first row. I circle its intersection. The remaining is what goes inside my little matrix, or my little determinant. C1, C2, and then we get A3. Right, how this pans out now is now we just have a bunch of small determinants. So I get B2, C3 minus B3, C2 times A1 minus B1, C3. It's just diagonal again. B1, C3 minus B3, C1, A2. And then plus, same thing, diagonal. B1, C2 minus B2, C1, A3. And that's how we determine a matrix, make a determinant, how we calculate a determinant. It is not pretty. The good thing is the method I gave you with the green highlighting and the diagonals and the circling actually makes it pretty easy. But without that, it is pretty difficult to remember. The way that the book gives it to you, let's just go ahead and take a look at that, is they're like, here's the, I'll give it a sec. Let's actually relate it. We have another multiplication. Remember, 11.3, we were talking about the next question, talking about vectors. We learned what a vector was. We learned about a vector in 3 space. We learned about multiplying a vector by a number. We also learned about adding vectors, subtracting vectors. So the next question that makes sense to ask is, what does multiplying look like? The first kind of multiplication that we had was the dot product. Now the second type of multiplication is called the cross product. It also has another name called the outer product. The dot product was the inner product. We're not going to use that, but you may in your future courses. So let's take a look at this definition. They give us U, they give us V, and then they say, okay, if I want to find the cross product, follow this giant formula. And automatically we hurt, right? That's so much to remember, and maybe you're great at memorization. That's fantastic. I am definitely not a great memorizer. My short-term memory is not great, and then it takes a while to get things into my long-term. So we actually have an algorithm. Algorithm means a method, right? A method to derive something, and it actually has to do with the determinant. If I write my u cross v like this in a determinant, right? I have u cross v. That's how we say that. Sorry, it's page is going crazy here. What I write down is I write aijk, and then I write the u vector and the v vector every single time. And the order matters. The u first and the v second. I, j, and k at the top. Now, using this, we are going to use our matrix definition from the last page. I do this. I look at the remaining matrix. All right, that's u2, u3, v2, and v3. And then I put an I. Just like we put A1 on that last one. We just put an I there now. That was the intersection. Okay, so now, going back here, second column, first row, the intersection is J. I do a minus. That's the minus that's always gets everybody. Almost got me just now. U1, U3, V1, V1, V3, J. And then we have our third one. It is the third column, the first row. Circle, that's what that outside is going to be. Plus, and I write down what's there. U1, U2, V1, V2, K. Now, I would work this out, right? I got U2, V3 minus U3, V2, I, minus U1, U3 minus U3, V1, J, plus U1, V2 minus U2, V1, K. And notice, this should be the same thing as that. Now, they may have things in different order, and that's okay. This should be, I think, a V right here. It looks like I put a U. It is the same definition, except for I didn't have to memorize that crazy long line. I just did this determinant method. Now, it looks like a lot, and it really is, but actually with real numbers in there, it goes really fast. It's pretty quick. We'll do some examples so you can see that. A couple things I do want to point out here. The dot product, when I did A dot B, this equaled a scalar. When I do A cross B, notice that my answer has something I, something j, something k. I'm not going to get a scalar. I'm going to get a vector. So the scalar product, or the dot product, gives me a scalar, or the vector product, or the cross product, gives me a vector. So a couple things. There's a very important, and the reason we're doing this cross product, and we're not going to get into the proof. We just don't have time with how many sections we have. If you are curious, I can send you a video with the proof in there of somebody else doing it. But it is a vector. That's the first thing. This second one is the big deal. U cross V, if I find it's a vector, remember, it is orthogonal to both U and V. Super powerful, right? What that means is if I have two vectors, right? Here's my two vectors. And they're flat on your screen. You're watching on your phone or computer or whatever, TV, I guess. If a vector is coming out of this point right here, that point coming out at you, it would be orthogonal to both vectors on the screen. Think about it. If the vector was coming out, this is coming out at you, that vector would be orthogonal to both. Or if it started here and poked into your screen, straight into it, it would be orthogonal. So when I find a U cross V, I am getting, it's almost like even taking our XY axis, right? This is X, Y. The Z is actually X cross Y. Or at least it's part of it. Anyways. We also have the other way around. V cross U is also a vector that's orthogonal to both. So we actually can do both ways and get two different ones. Now, this part is going to save us some work. U cross V is the same thing as V cross U with a negative. It's just the other way around. I actually will give this link in Blackboard if I can remember. If not, I would definitely Google this right-hand rule. The modality that we're using, I'm using an iPad, and I just don't have the want to make the camera to show you my hand, to show you how this rule works. This rule will determine when you do a cross, does the vector come out at you or did it go into the screen? Right? There's a way to actually determine that, and it's called the right-hand rule. It's really not difficult. I will put a link up sending you right to an explanation. If not, please just send me an email or text, and I will get that up. I'm just probably a day between uploading to the point of getting it in Blackboard. So if I forget, please forgive me. I will get it up there. All right, let's do an example. Okay, it says find two vectors that are orthogonal to both of the following vectors. All right, so I have u. I'm going to write this in component form because I like it. And then I also have v. And that's 2, 1, -1. And I want to find u cross v because I know that that will be orthogonal to both of the vectors. So I write this out. I, j, k. And then I put them in order. U goes first, so it goes first in the matrix. Write them all out. All right, and we're going to follow this formula now. So remember, this has to do with highlighting the top row and each column. All right, so I write down what's left. -1, 1, -2, -1 times I. The second one is always a minus. Cover that up, cover that up. The remaining is what goes inside. -5, 2, -2, -1. This is the j component. And then the last one here, we write down what's left, plus -5, 2, -1, 1. I always do a check here at this line. I always make sure none of the matrices are the same unless there are two columns that are the same above. Right, now I follow the formula. This is the diagonal thing now. Multiply minus multiply. Okay, so -1 times -1 is 1, minus a -2, so it's +2. I minus, I got 5, and I'm going to write this in just in case, minus -4, j. Let's do that on that first one too, because I want to make sure everybody knows we are subtracting. Plus, all right, and I got -5 minus a -2. Okay, and then we can get down to our answer. That's a 3i minus 9j minus 3k. So this vector that we just came out with, and we could even write this in component form if we wanted to. If we were to graph this vector and the two vectors we started with, this vector would be meet at a 90-degree angle with both vectors. It's orthogonal to both. That is one vector. They wanted two. So that was u cross v. Luckily, I can do v cross u, which just puts it out the other way. And I just do a negative u cross v. So that's -3, -9, -3, which means the other vector that is orthogonal is -3, 9, 3. You can look at these two. They are just opposite signs. So one goes one direction in orthogonally, the other one goes the other way. All right, so that's one example. These get easier with repetition. Unfortunately, it's like that. There are several topics in Calc 3 that are repetition based, and they do get fairly easy. Like this gets much easier once you do a bunch.